Okay, we've kind of beat around the bush a little bit about area, but now let's go ahead and dive right into area and definite integrals. Definite integral can represent area, but it doesn't always, so make sure you understand that not all definite integrals represent area. If f is continuous and non-negative on the closed interval a to b, then the area of the region bounded by the graph of f, the x-axis, the vertical lines x equal a and x equal b, is given by this formula. You simply integrate the function from a to b. Alright, so if you look over here to the right, basically this function here is a parabola. This is a parabola. Let's see if I can show you. So this is y equal x squared, or f of x equal x squared. Okay, now let's say that I want the area defined between x equal 1 and x equal 2. See if I can straighten that up for you there. Okay, so let's say I want the area bound here above the x-axis and below this graph. Well, actually, we're talking about this little area that maybe looks like a shard, or whatever you want to call it, right in here. Okay, let me see if I can shade it a little better. Okay, so I did the best I could here to try to show you. You see these bright blue, light blue boundaries? Okay, that is what I'm trying to do, is find the area inside there. But notice it's bounded on the left by the line x equal 1. It's bounded on the right by the line x equal 2. It's bounded below by the x-axis, and it's bounded above by the function y equal x squared. Okay, well, as long as the function here does not go below the x-axis from 1 to 2, then this integral will give you that area. Okay, so that integral will give you that area. Now, here's another example, and let me doctor it up for you. Okay, so here I have the function square root of x. That's what this graph right here is. And I want to find the area below this function above the x-axis from x equal 1 to x equal 4. And it turns out that all I have to do is evaluate the definite integral from x equal 1 to x equal 4, square root of x, and it will give me the area between this function and the x-axis from x equal 1 to x equal 4. And the reason is again, for both of these graphs, over the interval that I'm finding the area on the x-axis, the graphs do not go below. The graph is never negative. So it's important to keep that in mind. This only works as long as the graph is never negative. Okay, so first of all, verify that each of these problems below lie entirely above the x-axis over the interval. So I'll leave that for you to verify. But this one says find the area between the function f of x equal x squared, x equals 0 to x equal 2. Well, if you graph that, you're going to see that the graph's going to look something like this. So you're going to actually be finding this area. And the graph does not, from 0 to 2, the graph does not go below the x-axis. So all I have to do, just set up this integral, integrate from 0 to 2, x squared dx. And you already know how to do this. That's x cubed over 3, evaluate it from 0 to 2, and you get 8/3 minus 0, which is 8/3. All right, what if we wanted to go from, same function, but let's say we wanted to go from negative 1 to 2. Well, if we go from negative 1 to 2, that would be from here over to here. But still, the function y equal x squared does not go below the x-axis. So basically, I could just integrate from negative 1 to 2 this function, and it would give me the area between the function and the x-axis. So now do the same thing, but instead of integrating like from 0 to 2, I'm integrating from negative 1 to 2. So if you integrate from negative 1 to 2, you're going to get 8/3 minus negative 1/3, which is 8/3 plus 1/3, which is 3. Now, what if you wanted to find the area bounded by e to the x-axis from 0 to 2? Well, here's the graph of e to the x, and here's 0 right here, and then here's 2 right here. So basically I'm trying to find the area bounded in here above the x-axis and below that graph. Well, again, from 0 to 2, the graph never crosses the x-axis, so all I have to do is integrate from 0 to 2 e to the x. And when I do that, I get e to the x from 0 to 2, which is e squared minus e to the 0, which is e squared minus 1, so that area is about 6.389. The exact value is e squared minus 1. Okay, another one. Let's say I want to integrate 1 over x from 1 to 2. Okay, well here's the function 1 over x, and then here's x equal 1, and here's x equal 2. Notice that the function stays above the x-axis from 1 to 2. So therefore, I can use integrals to find the area bounded in here between the x-axis and this function. So I just integrate this function from 1 to 2. And remember, when you integrate 1 over x dx, that's just natural log of x. So evaluate that at 2, and I get natural log of 2 and minus natural log of 1. Of course, natural log of 1 is 0, so the answer is just natural log of 2. And natural log of 2 is about 0.693. Now, if the function lies entirely below the x-axis over the interval, then when you do the integral, you're actually going to get the opposite of the area. So you need to know that. So if someone said find the area between the function y equal x cubed, the x-axis, and negative 2 to 0, well then this is what it's going to look like. Okay, so here's negative 2, here's the negative 2, and of course 0 is right here, is just the x-axis. So you're actually trying to find the area between the x-axis and this function. But notice that this function lies entirely below the x-axis, and so when you evaluate this integral, if you integrate from negative 2 to 0, this function, it's actually going to give you negative the area. So you have to know that, so that after you finish the integration, so you know how to integrate this, so integrate this from negative 2 to 0, and you're going to get negative 4. But that's not the area. To get the area, you're going to have to take the opposite of that, and so that's going to be 4. Here's another one. If you graph this parabola, you'll see that you'll just get this piece right here. Okay, and we're going to evaluate it from 1 to 3. So here's 1 and here's 3. Okay, but notice the parabola lies entirely below the x-axis. This is the x-axis. So it lies entirely below. So basically you're looking for this area between the x-axis and the function, but since it lies entirely below, when you evaluate, when you integrate this from 1 to 3, it's actually going to give you negative the area. So you can go through and do the integration on your own, but once you integrate it and get that negative 46/3, to get area you have to change it to positive 46/3. Now, there's a big difference between solving a word problem like this, it's asking you to find area, and then someone just saying, hey, evaluate this integral. If someone said evaluate this integral, if that's all they said, then the answer would be negative 46/3. But here we've got to be smart, that we're wanting the area between the x-axis and this function. So once we see it's below the x-axis, then we know that we've got to take opposite of that so that to get the area. Take a moment and freeze the video and read the teacher's note here, and you can find that there's a lot of other applications that definite integrals can be used for. And then when you're finished reading, just go ahead and start the video back. Now, it turns out that if you want to find the area bounded between two curves, that's very simple. To find the area bounded between two curves, like let's say I want to find the area, let's say that this curve is f of x right here, and then this curve is g of x, the red curve is g of x. So if I want this area between them, this blue region, then all I have to do, and I want you to think about this, if I wanted the area between these two curves, if I want this blue area, well, think about it. If I integrate the function f of x from a to b, well, I'm just going to do a rough sketch. It's going to give me basically this region, right? Okay, so keep that in mind. Now then if I integrate g of x, it's going to basically give me this region right here. Okay, so let me change that color. So that'll give me that region. Okay, so if you take that region and subtract it from this region, you're actually going to be left with the blue region right here. And that's what we wanted to get. So in terms of area, it makes sense. So if you want the area bounded between two curves on an interval, then basically what you're going to do is you're going to take the area of the higher function and then subtract the area of the lower function. So you're going to subtract the two integrals where f of x is the higher function and g of x is the lower function. It could also be written like this. Okay, either way is fine. So it says find the area between the functions 2x and x squared over 0 to 2. Now, you graph the region, graph these on Desmos or whatever you want to use, and show that 2x from 0 to 2, 2x is the upper interval. So once you show that, then you know from 0 to 2, it's got to be in this order, 2x minus x squared from 0 to 2. And you know how to evaluate that integral, so I'm not going to get lost in the evaluation. So evaluate this definite integral, and you get 4/3. Now, if you get it backwards, if you do x squared minus 2x, it's going to give you the opposite answer. Okay, here's another one. Find the area between the regions of x squared minus 2 and e to the x from x equal 1 to 2. Okay, well again, graph the region, and you'll see that e to the x is going to be the higher region over that interval. So the area is going to be e to the x minus this function. So I'm going to have to integrate e to the x minus this function as x goes from 1 to 2. And you can go through and see how I did the integration there. It involves e to the x, though. Okay, let's finish up with one where you actually have to find points of intersection. This one says find the area between these two functions. Notice it doesn't give us an interval. The reason it doesn't give us an interval is basically because it looks like this. Okay, so basically if you graph this, the blue graph is y equal x squared and the red graph is y equal x plus 2. And so if it says find the area trapped between these two functions, well that would be this area in here. So but the problem is I know that if I go from this point to this point on the x-axis, I know that the red function, the line, is always on top. Okay, so that's not a big deal. So I know I'm going to integrate x plus 2 minus the parabola. But the question is, where do I integrate from? Well, you need to figure out what these x values are here and here so you can know your limits of integration. And so to do that, I just set the two functions equal and solve it. So x squared equal x plus 2 gives me x squared minus x minus 2 equals 0, which factors into x minus 2x plus 1. So from that, setting that equal to 0, I can solve that equation and find that x equal negative 1 and x equal 2 are the x values where these two functions intersect. So this point has to be x equal negative 1 and this point has to be x equal 2. So if I integrate the red function minus the blue function from negative 1 to 2, then that will give me the area. And the red function is the line, the blue function is the parabola, and integrate it from negative 1 to 2, and you'll get the area. And so again, I'll let you go through the integration process here, since I'm basically focusing on showing you area here, or how to do the area here, or set it up. And then there's a practice problem here below that you can do if you want to see, and the answer's given if you want to do it for practice to see if you can get that particular area. And so that ends the section on area. And anything I do after this may or may not be covered in your course. It just depends on how far or how deep your instructor goes in your business calculus course.